for 2-3 minutes for others to join. So before that, as you know, the last week you attended the exam in manufacturing tech. So I have been marking those exam 2 scripts now. There are some issues to be highlighted to you, particularly in the context of extended assignment, that is final exam in next week, maybe in next 2 weeks. So there also you have to be very careful in answering, because that is what you call a case study type of questions. So you need to answer on your own. There won't be any guidance to answer those questions. It's just like open-ended. Something like you see in one question in the exam 2, we have one question, a component is given and you are asked to find out what are the operations that are performed on that part to achieve that part. So that means some of you have turning, taper turning, knurling kind of operations. So that is good. So most of you answered, but you have not answered to get full marks, means 15 marks that question. Very few of you are getting 15 marks for that question. Why? Because you answered correct, but you answered as per the textbook, like drilling. So you put a drilling tool and then drilling hole at some point, but it's not required in your component. It's wrong. And also you should show it on your component, where is it drilling, how is it performed on that component. So with reference to your component, you should identify the operations that are performed. Everybody writes turning. Yes, the components given to you have turning, but that turning is taper turning for some part of the part, and taper turning, straight turning, knurling, threading. These are the different operations on that particular components that is given to you. You need to refer to that component, and you have to give the sketch of that particular component. Where is threading happening on that particular component? Where is taper turning happening on that particular component? Like that you have to answer. So in the upcoming external exam, in extended assignment also, you can expect such questions. Okay. So that is regarding what was happened in exam. So anyway, after everybody is here, we will finally at the end of the class also we will discuss once again what is the expected knowledge from you in the external extended assignment. So that thing we also discuss at the end of the class when everybody is in the room. So far only 40 people are in the room. Maybe at the end of this class, before dispersing, we will again see what is expected in extended assignment or the final exam, which will be in December. So let us see for the remaining part of machining operations. So in the previous class, we have drilling, before that reaming, before that lathe operations, and so on. So finally, let us come to another group of machine tools, or another group of operating machining operations. So we try to understand other kind of machining operations that are performed by different machine tools. Like in the previous classes, we learned lathe, drilling machine, shaping machine, planing machine, reamer, something like that. So there are certain operations which require different machine tools, different machine tools. We see those machine tools today. So let us start our lesson. Let me see how many, around 50, okay. Yeah, so today we're going to discuss other operations like as I said in the previous class, we discussed lathe and the operations that are possible with the lathe, like turning, paper turning, threading, making holes, drilling, boring, and so on. After that, we have seen another kind of machine tools like planing, shaper, which are fundamentally used for shaping plane surfaces or making plane machining. So that means shaper and planer. After that, we have seen another kind of a machine tool, that is drilling operation or drilling machines. So drilling operation is making holes, and then we have reamer. Reaming is to make finishing of the drilled hole, already drilled hole, and then boring. So these are the operations or the machines which we discussed in the last 2-3 weeks. So now finally we come to the last week, week number 12. So in this week we try to complete other machining, important machining. Of course, we are not covering everything on the earth, but we are covering important machining operations that are that we come across in every manufacturing. So the sawing is a simple operations, as you see on the slide. Hope you are able to see the slide. I think so. So in this sawing, a process to cut components, stock, etc. is a simple saw. That means to make work into two pieces, ripping or internal cut, as is shown in figure B, which is making some kind of a profile like thing, or angular cut in a tube, or a contour cutting or snack cutting. But normally sawing is generally like hacksaw, which we use to cut uh, or ripping the parts. So a simple machine, so nothing to worry about it, but just to introduce you, this is the one basic operations to get the plates of required size or the bars of required size, whatever it is. So you might have seen some of these sawing machines at places in workshop or domestic thing, which is like a band saw. The one is band saw, the other one is circular saw and circular saw, which we can see in many of the workshops and small areas, handheld hacksaw and so on. So hacksaw blade, if you see, or a band saw blade, it is the profile of the blade is so the profile of the blade is something like this, and then the spacing between two teeth is the one which decides whether that is a what kind of a blade it is, what kind of a material it can cut. So obviously it has certain styles which say that wave teeth or left right teeth or racket. So a simple thing which is not a very complex issue. So what is as a manufacturing point of view, this is of course it is not make any shapes. It is only to cut material into two pieces, or whenever you want to make some cutting, then we go for sawing. It is not actually machining. Actually speaking, machining is one which removes the material from the body or from the component. So for that point of view, it is not a machining operation. But still, we need this operation to make the work or metal pieces fair. So next important machine is milling machine, which is very versatile machine. versatile machine because it is used to manufacture many kind of ends. So this is a versatile process to cut arbitrary 3D shapes, like as you see in the case of sawing just now. That is not to cut any 3D shape or a profile like a hemisphere or a semicircular thing. That kind of a shape which is of this nature is not possible with other machines. So where this is a very versatile, which is used to cut 3D shapes, which is of gear or some profile or something like that. So the character of this process is high metal removal. That means it's very uh, heavy machining operations, and then high surface finish, and then very close dimension control. All these are the characteristics of this milling. So milling machines, though we are not very uh, completely or exhaustively dealing with milling types of milling machines, because there are many types of milling machines, but the most versatile milling machine which is very commonly used is column and knee type of milling machine. Column means this one, this is the column, and knee means this. So this is the type of machine which we can widely found in all workshops and very commonly seen milling machine. So column, there are as I said, there are many type: vertical milling machine, horizontal milling machine, so on. Some classifications. We are not looking at the classification, but we are taking a very popular and very widely used milling machine, which is of this orientation. So this orientation is column and knee type. Column means COLUMN. Column is which is vertical one, and knee is this one. Column and knee type. So both are column and knee type. Here in the picture, both are column and knee type. So what is column? Column means the vertical structure which support machine, and then the base. You know the base of the and then you have the table, work table. Say this is called work table. Work table is to mount the workpiece on which you wanted to machine or you wanted to remove the material. So this is the work, the which is held in the on the table. So workpiece is this one, and then saddle is the one which is able to move the workpiece or feed the workpiece against the tool. So knee is the one which is here on which the saddle is resting. Knee is can be raised or lowered. That means the knee can be raised up to accommodate the large workpiece. It can go back, it can go down. To accommodate the thin workpiece, it can come up so that it will be adjusted to meet the tool. So this is how it is there. So now as we see the pictures 1 and 2, both are column and knee type. Uh, both are column and knee type. Both have column, both have knee. So this is both are having column and knee. And then in this case, both cases, the saddle is there, and then saddle can be is the bottom of this, and then there is a table which is movable on left to right in the picture. So left to right. So everything is same. So what is the difference? Can anybody observe the difference and tell me? What is the difference between those two figures? So lateral cut and axial cut, the direction. Yeah, the direction of what, Mr. Tash? You are so close. What is the direction? Direction of what? Direction of movement of the work is same. It is both the case. The yeah, the in both the cases, in both the tables, the table is moving left and right. Cutting direction or direction of cutter axis. Yes, Parasha is correct. So if you observe the uh, tool axis, that means the milling cutter. The milling cutter axis is different. That is why they are now. I can classify. There is one more classification, that is horizontal milling machine, horizontal type milling machine, where horizontal, the axis of the cutter is, you see here the cutter is mounted on the thing which is horizontal. That means the cutter axis is horizontal, whereas here the cutter axis is vertical. So cutter is here, milling cutter is here. So the metal in the picture 1 or on the picture this, let me call it as A. In the picture A, the tool is mounted horizontal axis on the mounted on the horizontal axis, whereas on the B the tool is mounted on the vertical axis. So one another classification of the machine is vertical milling machine, horizontal milling machine. What is vertical milling machine? What is vertical? The tool axis is vertical, the tool axis is horizontal. So if you now would like to say what is that, the figure number A, figure A is horizontal column and knee type milling machine. Horizontal column and knee type milling machine. This is vertical column and knee machine. What is vertical? What is horizontal? Vertical means vertical axis. The axis of the tool is vertical. That means the tool is mounted vertically. Here the tool is mounted on a horizontal axis. So that is the difference. But both have some advantages, advantages as well as some uh, some applications. Let us see what is that and how we are going to, when we require this kind of arrangement, when we kind of this kind of arrangement. It depends on the your applications. For example, if you see here the picture that is shown here, the milling machine is also can be able to cut the T slots like this slots. This is very, it is not completed in one go, it will be completed in several goes, but the milling machine can be used to do that. Similarly, the milling machine is used to get this kind of a profile, or you can have this kind of a profile. Everything is possible with the milling machine, but the only thing is you have to choose particular type of tool. Milling cutters are many, we have to choose a particular type of cutter. Let us see what is that type of cutters. So is it clear? So we move to next slide. So here these are the cutters, some of the cutters, not all cutters. This is vertical milling cutters. So some of the common vertical milling cutters. In the case of here, this is horizontal milling cutter. You see here, this horizontal milling cutter is somewhat wider. It is like a cylinder. It is like a cylinder with all that. So that is called slab milling cutter. Slab milling cutter. Slab means some area it will cover. Whereas this one is vertical. So in the vertical things we have different cutters like flat flute, like milling cutter can be a vertical, which looks like our drilling bit. This is exactly like a drilling bit, but this is not. This is straight here. It is having a semi-circular or hemispherical end. So that means when you program, actually the milling machines, of course, if you do it manually, you know what you are doing. If you are programming it, what happens is this is the tool tip. Tool tip is this point, the point. So which is when you program the move to some x to y. X to y means some x comma y. So x comma y, when it reaches here, that is x comma y. But actually the tool is not. But whereas here, if you say x dot y, it is exactly all that surface is going there. Whereas here only tip is going there. Whereas here in the other case, only the ball nose is a part of it is going, but still, of course, it is a wider area, not as point as like this. So this is the things which we keep in mind while programming with milling cutters. Now, of course, this is when you use CNC machine, all that is we trained for that, and we know. So let us come to the types of milling. As I said, there are different types of milling cutters as well as milling operations. We classify it based on different factors. One factor is based on machine type of milling machine that is used. Type of milling machine that is used is horizontal milling machine or vertical milling machine, which means the one which is shown in the previous slide. So there is a operation, the type of operation, how we are operating the milling cutter. Based on that, we have some classification that is called type up milling and down milling. So basically, the broad classification of milling is down milling, up milling. What is up milling? Up milling, also called as conventional milling, in which the workpiece is moving towards the cutter, opposing the cutter direction of rotation. That means in the up milling, suppose it is here conventional. Conventional means very obviously used. So in the very obviously used or conventional machining up milling, the tool is rotating in the, suppose, in the anti-clockwise direction, whereas the feed is horizontal. That means your work is traveling in this direction, whereas your tool is pushing in this direction. That means they are in opposite direction. So the cutter and the feed movement are opposite to each other. That means the vector, velocity vector, is pushing this, whereas the feed is pushing this. So that is called, if that is the type of setup, then we call it as conventional milling. Conventional milling means the workpiece is fed. The workpiece is fed against the tool. Tool is rotating in this direction. So that means it is going like this, and you are pushing like this. So that is called conventional milling. So the direction of cutting force, because it is touching here and then slowly increasing the depth of cut. Therefore, that means the shape of that is chip is like this. Huh? The shape of the chip is like this. That means initially the tool is just touching here. So initially the tool just touching here, and then the it is as because it is pushing in the, as it is pushing in this direction, therefore the thickness increases. So it starts at very zero thickness. As we feed, it goes to final thickness. Say suppose final thickness is x. So it starts at 0 and goes to x. So that is in the, and then direction of force is try to pull this up. That means it will push the workpiece away from the tool. So because it is of the dynamic, because of the nature of it. Similarly, when come to the down milling or climb milling, where the cutter rotation is same direction as that of the motion of the workpiece. Why? Because suppose if it is now that tool direction is reversed, that means it is in the clockwise. That means the tool is moving in this direction, as well as the feed is also in this direction. So what happens is the tooth, milling cutter tooth, will hit the workpiece here. That means at maximum, and because both are moving at the same rate in the same direction, so cutting. So when you look at the chip in this case is something like this, where it starts here. That means it starts with x and end with 0. So initially it hits at the x position. That means with the x thickness, and slowly it removes. That means that is the difference between, what is the difference between up milling and down milling? Up milling, cutter and feed direction are opposite to each other. Therefore, the the chip thickness or the cutting starts with 0 thickness and improves to x, whatever x you are providing. Whereas in the down milling, it starts at x. That means the depth of cut, suppose 2 mm, it starts at 2 mm and then goes to 0. So this is the basic difference between up milling and down milling. Up milling is called conventional milling because it is most widely used, but the difference is here is, it is already written here, cutting edge takes full thickness of the cut at entry and exits at 0. Whereas here, the vice versa, it it enters at 0 and improves to final thickness, that is cutting edge thickness. So thin cut at entry with abrupt exit, whereas here the maximum cut at entry and it exits smoothly. So exit is smooth here, whereas exit is abrupt here. So therefore, That is the difference between these two. And then cutting force also, you can see here, the cutting force is acting because it is hitting here, it will hit here because the cutting force is in this direction. Whereas here the cutting force is pushing the material out. That means in the conventional milling, the workpiece is trying to come out of the vise because this is fitted to vise. Because the workpiece always, as you see in the previous diagram, the workpiece is fitted to what you call in this case, because now we are discussing the slab milling. So here in this case, the work is fitted to workpiece, so that is the try to come out in case of a up milling. So that is regarding one type of classification. So if you have any doubts here, we will take up now. So any doubts we will take. Is anyone waiting for us? So any questions? If you have any doubts, we will take. Otherwise, we move to next. Sir, which one is more effective? That's a good question. Which one is more effective means it depends on what is your application. For example, your intention is both are having some advantage and disadvantage. Let me list out the advantage and disadvantage based on situation you choose. So one difference already listed out. What is that difference is? You have the force in this case. The force in this case is try to the cutting force here. The cutting force direction of cutting force is pushing it downward. Means it is easy to grab or easy to fit the material to the vise because it is also pushing down and you are already having your table on the bottom, so therefore it is stable. Whereas here it is trying to pick it up, so therefore if you don't fix correctly, the work is trying to come out of the vise. That means you need to have good fixture to hold the workpiece in case of up milling, because the direction of force is to pull up, whereas here the direction of force is to pull down. So therefore it is pull down, no problem, because it's already a table, so it is touching against the fitting against the. So one difference is that. Another difference is as you are asking, so which is better? When you take the zero cut here and slowly increasing your cut, that means thin cut at entry and with the abrasives. Because it is taking thin cut at entry, that means your tool is subjected to gradual increase of the force. Gradual increase. That means because here depth of cut is zero here, slowly it increases, and therefore the load increases gradually. So in this case, that is like that. Whereas in this case, the load hit maximum, the full thickness at the entrance. That means it takes full force at the entrance and slowly decreasing. So which is better? Now you tell me which is better, whether you take the slow load and go slowly increasing better, or just have the maximum load at the entrance and then slowly decreasing load. Which is better, and why you think that is better? Which is better, having Farasha, which is better, having high load at the initial and then going slowly down, or having low force at the beginning and gradually increasing maximum load at the end? Which is better? In up milling, you see gradually increasing. In down milling or climb milling, it hits and then reducing. Which is better? So you think up milling is better because the load is increasing gradually. Is it right? So what is the disadvantage in having the other case is the down milling is, as you said, you think it is better. Why it is better? Because you think that the loading gradually is increasing. For anybody, slowly increasing load is better than hitting it with a maximum load. That is called impact load. Anytime we say when it is impact load means sudden load, say suddenly you give 20 Newton and go to 0. Whereas here you give 0 Newton and go to 20 kilonewton. So that is the difference. So that way it is better, but there is some disadvantage. If that is better, why should we go for down milling? If up milling is better, why everybody is not going up milling? Because as per the my conversation with you now, up milling is better because it gradually increases the load onto the cutter tooth. Hence, the tooth is safe. Safe because you gradually increasing load on the tooth, so therefore the tooth will be sustain the load. Whereas other case, climb milling, tooth is subjected to sudden load, that means impact load, then 20 kilonewton go to 0. But when it is suddenly applied 20 kilonewton, there is an impact which is causing vibration. So this is actually the disadvantage. It is impact load causes the, though the one disadvantage is up milling, difficult to hold the workpiece because the force are acting upwards. Therefore, the workpiece is try to pushing out, pulling. Therefore, you need to have the better, what you call, better vice and fixing features to hold the workpiece in case of up milling. Whereas in case of down milling, easy to fix because already it is hitting the ground. Therefore, it is easy. But the disadvantage is the tool is subjected to sudden load, which causes vibration. Because sudden load, therefore it vibrates. That means suddenly it gives, then 20 kilonewton goes to 0, then 20 kilonewtons goes to 0. Like that, it gives impact load at certain frequencies. So therefore, that is a disadvantage for vibration point of view. But still, why we use up milling in some cases, why we use down milling in some cases is another disadvantage is there with up milling. That disadvantage is the thing here, the disadvantage here is in the case of up milling, the chips, that means the chips that are coming up are accumulated here. So the chips, suppose I am not showing here, so the chips, all these red marks are, let us say, chips. So they accumulate here because as you machine it, they pile up the chips like this. Whereas here, that creates, after some time, that creates, the chips are clogged to these gaps. So that creates some kind of a nuisance to the tool or surface finish. Whereas here, it is hit and then goes back. So ahead of the tool in the down milling, it is clear there is no chips. That means in the down milling, ahead of the tool, that means always the tool hits the new surface. There is no chips because the chips are thrown away this side. The chips are here, of course, somewhere here, already machined part. So no problem. But whereas here the chips are ahead of milling cutter, means the cutting edge, the what you call the surface that is to be machined. So that causes some kind of a what you call disturbance and the surface finish problems with surface finish. So therefore, if you have that kind of a machining, that means you want to machine huge amounts, then we go for down milling. When you want to machine for that say very little depth of cuts, then we go for conventional milling. So this is the selection. When you go for this, when you go for. So when you want to cut a big depth of cuts with huge material removal, then we go for climb milling because the chip disposal is easy and also the holding the workpiece is also easy because the force is downwards. Whereas if your intention is to have the finish cut, no no vibration, no surface finish point of view, you don't want to take any chance, then we go for it. So that is how we select our type of milling, whether you fix it like this or this is of course it's only direction of feed. There is nothing like you are not changing anything, only you are changing the direction of milling, whether to feed the direction in this direction or on the other direction. So you choose the direction based on your application. Your application is very huge material is removed, then we go for this. If application is light material removal, we go for this because there uh, chips is not the problem, the surface finish is the problem. So this is how we select up milling and down milling and relative advantage and disadvantages based on your need. We choose to machine in a down milling way or up milling way. So this is the difference. So now coming to other aspects of milling, peripheral milling is another one. So other aspects of the milling means. So I think we proceed. Any doubts? Yeah. If you don't have any doubts, we just let us go for milling. So peripheral milling means you wanted to machine. So this is you see here this figure. Peripheral milling means periphery means surface, outside. So peripheral slab milling operation means this kind of a cutter, milling cutter. You see, this is a slab cutter where it machines some area, not a slot. So periphery milling operations over an area is called slab milling. So slab milling operation, that means particular area, say some depth and some width. Then it depends on what is your cutter width. Cutter width is say W, so you will get W as this width of cutting. And then depth of cut is of course how much you penetrate into this. So this is depth of cut, this is width of cut, and that depends on width of the cutter. Your cutter is say 2 centimeters, you get 2 centimeters slab. Cutter is 50 millimeter, that means 5 centimeters, then you get slab of 50 mm. So that is slab milling cutter. And then slot milling cutter, where the cutter is having to cut these slots like this. This is also of course peripheral milling on the surface. Periphery means outside. So narrow cuts. And then straddle cutting. Straddle cutting means more than one tool can be fixed to the arms, like in the case of we go back here. So this is a slab milling cutter, single slab milling cutter, the one which is shown in this figure. Whereas you can put 2-3 tools also, as we see here. That is straddle milling. Straddle milling is the one where you on the horizontal axis you have one cutter, another cutter, maybe 2-3. 2 slots are shown here. So that is straddle cutting, means many cutters. You can say there is also another milling called gang milling. It's not shown in this figure. So slitting is only to just like sawing, as we see in the sawing machine. So it is to cut a big material into. This is slitter, which is simply as a saw, as we see in the previous one of the previous slides. So slab milling, in the peripheral milling, you have these many varieties. Periphery means, as I said, outside machining. So peripheral slab milling, peripheral slotting, peripheral straddle milling means more than one tool, and slitting to cut. So this is one another classification or another a variety of milling. Let us see in the one which we have seen in the previous case is called peripheral. This is called face milling. Face is here. If you see the partial face milling operation, the face milling cutter machines only on one side of the machine. That means, so in the face milling cutter, the milling is happening on the face of it. That means these are the face milling cutters. Say for example, can I zoom it? So if you see here, this one is having a teeth. You see here the teeth, something. So they cut the material here or the on the face. That means in this figure, the material is removed on the from the face, not from here, not from this portion. This is not cutting. The only cutting action takes place at the face. That means on a horizontal surface, not on the vertical surface. So face milling operation, if you look at here, the face milling operation, there won't be any cutting takes place with this teeth. Here, no cutter. The cutting action takes place at the bottom. So this is face. So face milling cutter means it cuts here. The tooth are here. There is no cutting on this. Though the figure this is shown in the figure, having some thickness of the tool is not, these are not the cutting edges. The cutting edge is at the bottom. That means only to machine face. So conventional face milling operation, cutter machines the entire surface. The cutter depth is greater than the work width. I will show you one video how the face milling cutter looks like, how it participates. But the face milling, if you compare now, peripheral milling is different. Peripheral milling, why? Because peripheral milling, the tooth are participating. All the tooth that is in the here is participating, not the face. Whereas in the face, here only face of the tool is participating in cutting, not the side edges. So face milling is to machine the faces. Let us see the video. If you have any doubts after the video, we will discuss. Okay. So the one that is shown now is face milling. Face milling, as I said, the cutting tooth is only having on the bottom surface. That is face. It machines this face with the help of face milling. So if you see, look at now so the face that is machined is here. That is which is glowing. The face that is originally is there. That is in the aluminum. So the difference between already milled surface and unmilled surface, unmachined. You see now in the second round. So the machining is based on face milling cutter. So the face milling cutter has cutting tooth on the bottom. So this you can see here. This is machined surface. This is unmachined surface. So now the other is end milling. End milling is slightly different from face milling. Let us see the difference, and you try to understand how is it different. From the figure, from the video, if you try to understand, if not, I will give you the sketches. So you understand here what is happening there. So this is called end milling. In the previous case, that one is face milling. Face milling, you know, you have no doubts, I think, because we already shown some sketch, and then we see the face milling aspect. Now end milling, just identify what is the difference in this. So you, I think you observe. So you may let us see once again. You can observe now what is happening in face milling, what is happening in end milling. So so end milling is like a smoothened surface. Face milling is horizontal, while milling is vertical. Not only that, actually, face milling, as I said, face milling has cutter tooth on face of the tool, whereas end milling, name itself indicates, it has tooth on ends. But the operation is slightly different. In case of end milling, you have the both. It also cuts. I think we don't have the figure. Huh? So in the case of end milling, if you see it is also Mr. Che is mentioning here, end milling is like smoothen the surface. It is not smoothen the surface. It is making the hole. It is removing the material, but it is removing the material with the help of both face and side. So that is end milling cutter. So you can see here, if you let us go back to that, give more supporting statement. Mr. Che. So the statement he says is somewhat you have to understand. So in this case, if you see in this space milling, what we are saying is it is cutting only uh, at this surface. It is not participating with this cutter. Whereas in end milling case, in the this is that is why here if you look at this, the heading is partial, huh? Whereas here it's milling. So why? Because if these are participating in the cutting action, then it is not pure face milling. This is normal slab milling cutter. In the case of slab milling cutter, you see here the slab milling cutter, whatever cutter we are showing here, they will not have any teeth on the face. This is the slab milling cutter. This is one is also slab milling cutter because they don't have anything. Whereas here, if you see the other type, the milling cutters, some of them has having the cutter at the end. They are the face milling, actual face milling type cutters. So in this case, face milling, pure face milling means there is no cutter at this edge. Actually, there is no cutting edge, and just to see whether it is participating. Whereas in this figure, it is showing some kind of a thickness for the tool, and then that is having some tooth. So that is why it is named as partial filling. It will not, because if these are participating in cutting, that is called partial. It is not a pure face milling. It means the things are also uh, cutting. The edges are also cutting in this face. Whereas in the case of end milling here, this is pure face milling, no controversy, nothing, because the face of the tool is only having the cutting tooth, and then it is. So the depth of cut is, you can see from the figure, the depth of cut is this much. So maybe. Also, when you observe next time, now you see the tool. The tool is having, it is something like drill bit. If it looks like drill bit, as we see in the previous 2-3 slides back, milling cutters, they will have both face as well as flute also. They will have flute like drill bit. If you see this one, it is creating a, it is milling at the ends. That means it is creating a slot over the surface of the plate. That means the material is some shape. That shape can be a rectangular hole or a curvilinear hole or some parabolic hole, whatever it is, as per the program. It is a CNC machine. So if you see here, it cuts both at the edges and also at the bottom. That means it is having the cutting tooth at the end as well as at the face, just as we show in the previous slide over 3 types of tools. And one more thing you observe, and some tool here is here. It is like drill bit. Is the drill bit. Similar to that, this end mill also looks like that. It is actually cutting the shape. The groove is programmed. So according to the program, the, and also observe which is moving, whether tool is moving or table is moving. So actually, I can show you the tool because it is. So that is how it is making cut and mill in the case of hand mill. So you can also have another variety called slot cutting. Slot cutting is, as we see, to cut this kind of a slot. Of course, it is not in a single cut. So in the first cut, it only makes a small groove with the help of normal slot cutter, and then we can have a second slot which is in the bottom shape. That means this one. So initially you cut first slot, then extend it by using a different slot cutting milling. So this first cut can be with any of the tool like shell mill or any milling cutter, but this one is a slot cutter. So depending upon the shape of the machined object, we select the tools. Different milling cutters are available. Like form cutting, if you want to cut the gears, we use the form of that type. I think I don't show that the previous thing video, but if you want to cut like in the slot cutting, if you want to cut a gear, you have a gear type of tool, which is in the case of straddle milling. Straddle milling, if you have a form form cutter, that means form milling cutter. Form cutter means form means the shape which you want to create. The shape which you want to create is a layer, a gear. That is a gear type. If the shape that you want to have a slotting is cut, that is form cutters to machine. Gears also can be machined by milling machine by normal milling cutters by adjusting or programming the movements. But there are some cases where for final touching you use gear forming machine where the tool is gear forming tool. So that is regarding the milling. So final operation, which after machining everything, we need to perform finishing operation, a series of finishing operations, not one. Actually, in industry, a series of operations, but very important operation, finishing operation is grinding. So grinding is also has several types of machines. Uh, Before going to grinding, we will have some break and then we will go to grinding. So if you have any questions, we take questions now on milling. CNC milling, it is CNC, not CLC, CNC. Computer numerical control. Okay, CNC stands for computer numerical control. That of course we are not dealing with CNC machines in this class. We deal with that in advanced manufacturing as well as manufacturing. But anyway, I think some labs you have that programming. In this semester also, we did some lab. So that is CNC. Maybe you type it. Uh, okay. Suppose if you don't have any questions, we will take 5 minutes break. And after the break, we will have a small quiz. Before the break, you please answer the SSRT survey now. If you have not answered, because only 60 people have answered, another 60 people, 40 people has to answer. So please answer now in this break the SSRT survey, that is self-reflection tool, which is already you might have done for many of the subjects. So now 1033 manufacturing technology, try to do it now. After this, we will have quiz. Another 5 minutes, we will come back and we will have quiz, and then we continue our lesson. Okay, please do SSRT now. Those who have not done, I will see now whether any new participations are there or not. Only I receive only 60 participants. I need all 100 participants to participate. Please participate now if you have not done. So you can answer. Some of you are already started answering quiz on Teams platform. You can do and finish it. Those who have not seen, just they can see the now and answer your quiz now. That is on milling operations. Just now what we discussed. Just answer that survey and also this quiz. So we start our lesson at 5:10. So welcome back. We come to our lesson. Did you answer? Anybody answered SSRT? I think nobody. I have not seen anybody answer anything. So I need, as I told you, at least after the class, you must answer SSRT for manufacturing technology because we are in the last week, so we don't have any time. So we must finish that SSRT in this week itself. So by today itself, okay. So we continue our lesson. If you have answered your quiz just now on Teams platform, I think most of you have answered. Who are in the class, they have answered, and then I think you got full marks. Huh? If any of you got full. not everybody, at least a majority of them got 5. So coming to the point, so why we need another operation? So when you do uh, casting, machining, or any other process like even welding also, after every operation, you are end up with some object, say casting, you end up with some cast part, but that part is not good enough to use it uh, as it is, because it is having all that roughness on the surface, and then it is not shiny, and the dimensions are not correct exactly same. So we need to do something to make it attractive, as well as surface finish should be good. So to get required surface finish and also dimensional accuracy, we need an operation called grinding operation. So let us see what is it. So this is a process to finish and smooth surfaces. As I said, if we have anything and that part will undergo this operation, that operation is grinding operation, or it is also called abrasive machining. Abrasive machining means instead of tool here, we use abrasive particles, means rough particles. So that abrasive particles are the tools here, not the single point tool like we see in the high speed steel, carbide tools like that. We don't have a tool, but we have a tool material, and then we have abrasive particle which acts as a cutter here. So what is it? Let us say, though metal removal rate is very, very low in this case, because as I said, this is only a finishing operation. Therefore, no metal removal rate expected here, is very low. Very high surface finish is expected, and very dimensional control is expected, because this is the prime motive for grinding. So what are the objectives? Objective is to improve the surface finish of a part. Let us say if some object is prepared by molding injection die, then, or if it is a milled, and then manually you have to go for grinding with manual or something. Cylinder of engine, if it is uh, cast, for example, then you have to turn it for the required shapes, and then grinding, honing, and lapping. So actually, honing and lapping is also a grinding finishing process. If you do very fine tuning, that is called honing, and also lapping is the rubbing. This is actually, all this comes under grinding only. Honing, lapping, and grinding, they are a family. A family means, like in the milling, we have slab milling, end milling, side milling, like that. Here also grinding, honing, lapping is also a subset of grinding, where very fine tune or very fine finishing operations are called honing and lapping. To improve the dimensional tolerance is another objective for the grinding. For example, in case of ball bearings, for example, the ball bearing, where the ball bearings are manufactured by forging. I think you don't know forging, because we have not discussed with this part. But forging is also one type of manufacturing thing, and then after forging we have to grind it to control, to get the finishing of 15 microns and so. And then knives, you see, the knives which you use in your house is made up of forged steel, and sometimes you also uh, grind it. So sometimes we this is the grinding to improve the surface finish is one, and to improve the dimensional accuracy is another one. As I said, the knives are made up of forged steel, and then they harden to retain the hardness when you use it as a cutter. then grind it. So this grinding we also do whenever the knife lost its sharpness, you grind. So the process that you do it for knives to resharpen, that is nothing but grinding. So to cut hard brittle materials like some semiconductor IC chips, and then to remove unwanted materials in case of cutting process. Like drilling, after drilling, you left with the deburs. After milling, you left with deburs. That means small chip particles stuck to that. So that one is also removed by grinding. So these are the some of the uh, motives or purpose of grinding. So these are the tools which we can observe in the grinding. So normally grinding is like the paper which you use in your metallurgy or material science lab, abrasive wheel or a paper or tools. So sometimes we come across this kind of a wheel in many of your domestic or small workshops, and then we come across paper, so abrasive paper for our metallurgical process. And then also sometimes we see the silicon wafers in finishing the surfaces. These are the examples of grinding machines. So this is one grinding machine, which is surface grinder. I will show you later what is a surface grinder and how it works. And then grinding of small bench grinders. These are called bench grinders. And then centerless grinders. So this is some of the varieties of grinding machines. Bench grinder, surface grinder, centralized grinder. So I will show you the working also. So how it looks like sandpaper, for example, uh, how the abrasive particles are placed. The series of randomly shaped instantaneous cutting edges result in a straight composite cutting edge. So that means the small abrasive particles that are laid on the paper, they work as a cutting tool, and they make the cutting edges and then perform. Suppose this is the work. The work is uh, ground by a sandpaper. So suppose if you apply a sandpaper on a rough surface to make it smoother, how it makes smoother is the cutting edges that are formed because of this abrasive particles, they will um, participate as a cutting tool and remove the finest particles from the surface. So the finest particles that are removed by these abrasive gains. So based on the sandpaper number, say 90 microns, 60 microns, like that. So we will have that abrasive particle grains size. How a machine looks like the one which I have shown in the previous thing is abrasive paper that is used to make the finishing of the surface. Whereas when a grinding machine using a grinding wheel, so if it is in the form of a grinding wheel, what are the conditions and what is that part? So if this is the part which is to be machined, and the machine is the part is moving with a velocity of VW, uh, that is against the work. You can have two types. Either wheel can be moved or work can be moved. Whatever it is, the relative velocity is VW. And then the depth of cut is D. So the depth that is obtained in the cutting is depth of cut. And then width of the wheel is nothing but width of the material that is removed. So the shaded area here, CSA is what? Cross-sectional area. So the cross-sectional area is the one which is removed from this part. So the geometry of the surface grinding is like D is the small d, depth of cut. Capital D is the diameter of the workpiece, diameter of the wheel. Actually, the wheel is 4 now, so the D is reducing. Of course, that is, we are not worried about this one now. What we are worried about is we are worried about the material that is removed. That is material removal rate. The material that is removed is depth of cut D, and width of the wheel, that is V times D times W is the CSA. That means CSA means cross sectional area. So this is how we calculate if there is a calculation involved in what is the time that is required to cut. All that is similar to our previous operations. V is equal to pi dn, where D stands for diameter of the wheel, N stands for the rotation of the wheel, rotational speed of the wheel. Depth of cut, as I said, what is the depth that you give, that is in feet. And then width is, width of that wheel, width of the cut. So this is what we are, metal removal rate is velocity times CSA. CSA is cross-sectional area. That means velocity times area is the metal removal rate. So this is how we calculate how fast it is going to remove our material. So CSA is cross feet times in feet. So what are the materials that we use for these abrasive particles? The materials that we use for these abrasive particles is listed here. They are listed here. That is abrasive material is aluminum oxide. It may be a 97% to 99% aluminum oxide, whereas silicon carbide may be 96 to 99%, and then CBN, that is cubic boron nitride, synthetic diamond. So these are the abrasive particles. The work material with these particles is, that means aluminum oxide wheels can be used to machine this kind of a steel, hardened steel, cast iron, etc. Whereas silicon carbide can be used of the same thing, but in addition to that, some brass, etc. And then tool steels, aerospace alloys, etc. We use CBN as the abrasive material. So this is the how to select an abrasive wheel. That is because the grinding wheels are made up of several abrasives as listed here: aluminum oxide, silicon carbide, CBN, and of course their cost also is vary. So depending upon what is your work material, that means you are going to work on ceramics, or you are going to work on high speed steel, or you are going to work on aluminum, brass, brittle materials like that, then that is how it we select the abrasive material. So basically abrasive materials are silicon carbide, aluminum oxide, and CBN. So now finally come to what are the operations, grinding operations. So grinding operations, we have grinding operations are carried out with a variety of wheel work combinations. So based on this work wheel combination, grinding operations are classified as surface grinder or surface grinding, cylindrical grinding, centerless grinding. Surface grinding means grinding on the surface. Cylindrical grinding means grinding the cylindrical surfaces. What is centerless grinding then? So if I say surface grinding is to make surfaces, to grind surfaces. Cylindrical grinding is to make cylindrical pieces grinding. Then what is centerless grinding? So it is not as simple as that. So it is the principle that we use to make the centerless grinding means the principle that we use to make the grinding operation. So broadly, grinding operations are three varieties or three types of operations. One is surface grinding, second one is cylindrical grinding, third one is centerless grinding. So cylindrical grinding and centerless grinding is actually, they are to grind cylindrical workpieces or cylindrical components. But the principle between these two is slightly different. That is why it is called centerless grinding. So let us see what is it and how is it. So surface grinding means, as you see, the surface grinding is an abrasive machining process in which the grinding wheel removes material from the flat surfaces. So this is the work. We have work here, and then we have wheel here, that we know the abrasive wheel, and then it is moving on. Either as I said, either you can move the work, that means you can feed the work, or sometimes the wheel can also be moved, which be based on what is your setup or what is your machine. So normally surface grinding machines, the table is moving to and fro. That means back and forth. So we'll see that in that video also how the surface grinding. So surface grinding means making grinding operation or abrasive machining operation on flat surface. So that is clear. Surface grinding is to machine surface flat surfaces. So obviously cylindrical grinding is as I said previously. So surface grinding examples are more examples are given here, using a grinding wheel as we see, or using a work part which is a circular work part, but we want to make the grinding on this surface, then this is called surface grinding, or work part of this shape. We can also have a grinding wheel in this fashion, which is not only on the periphery. You can use it as a rubbing action. That means flat grinding wheels. So four types of surface grinding: horizontal, vertical spindles, as well as reciprocating and rotating motion. So these are the different layouts of surface grinding. Surface is the one which is grinding, but based on the wheel and wheel orientation, we have some configurations here. So let us see the cylindrical grinding. Cylindrical grinding, as I said, it is to machine cylindrical parts, as it is shown in the figure here also. The surface grinding is wheel is here, and this is the part which is to be ground. So this one is the depth of cut for that grinding. So this figure is external grinding. This figure is internal grinding. Internal grinding means the surface, the grinding that is happening here is to the internal surface. So this is called internal grinding. But of course, both are cylindrical grinding only. Only thing is whether you are machining external surface or whether you are machining internal surface. That is the only difference between these two orientations. But principle wise, it's a single principle cylindrical grinding. So now comes to the centerless grinding. What is centerless grinding? You are very clear about what is surface grinding because the name itself indicates what is it, and you have seen the sketches to understand it in a better way. Now cylindrical grinding also, you know what is cylindrical grinding from the name as well as from the sketches. Can anybody guess what is centerless grinding? Maybe what centralized grinding can be. So centralized grinding means, let us see what is it. Actually, the principle behind working is based on that, the name implied centralized grinding. So before going to that, we have some definitions here for the speed motion and all. Let me show you centralized grinding and we can come back. So centralized grinding means this one. So here the workpiece is held. The workpiece is held between two rotating wheels. So this is one wheel. This is another wheel. So one wheel is grinding wheel. The other wheel is supporting wheel. For example, this one. The small wheel in this figure is a regulating wheel. The small wheel that is in the figure is a regulating wheel. The one that is bigger here is a grinding wheel. And the workpiece is also a cylindrical workpiece, which is fed through this. Why this is called centerless grinding is the work is not held between centers. Whereas in the previous cases, to grind, the work is to be, suppose this is the workpiece, this is to be fitted to between the centers. That means between a chuck or between the centers of a lathe, or it is to be held by something. Here it is not held by anything. It is a free workpiece which is fed between the wheels. So the wheels are so arranged that the regulating wheel is at some inclination, which is to guide or to throw the cylindrical workpiece that is fed here. So because of this angle, the frictional force drive this workpiece to move slowly as the rotation passes. So during the rotation, the work is moving automatically because of the friction between regulating wheel and the workpiece. Whereas this grinding wheel participates in removal of the material. So that is why this is called centerless grinding. Centerless grinding means it is not held in between centers. The work is not held. That is the meaning of that. So that is how the name applies. So now coming to the three types of fluid motions. traverse feeding, plunge feeding, and then combination of traverse and wheel. So what is traverse? Traverse is clear. Cross feed is given to this. The feed grinding in which the relative feed motion is parallel to the spindle of the axis of rotation, whereas plunge grinding is radially in the workpiece, and that means in this case the work is moving here cross feed, whereas here the cross feed is in this direction vertical. That means it is pressing against it, and hence you are going to have that depth of cut on the material. Whereas combination of traverse and plunge is the work grinding wheel is at some angle. You see here that is 45 degrees angle. So the grinding wheel is held at 45 degrees, and then both cross feed and this linear feed are given simultaneously. So this is called a combination of traverse and plunge grinding. So traverse grinding means simple. Plunge grinding means you are plunging or applying against the work. So these are the three major types of grinding operations. One is surface grinding, cylindrical grinding, and centerless grinding. Let us see how they work. So you can watch this video to understand the surface grinding, centerless grinding, and cylindrical grinding. So let us go here. This is an animation, no problem. It is very clear. We have any doubts, we can discuss again. So this animation is about external cylindrical grinding, where this is the part which is the work is held. When I say centerless grinding, I said because the workpiece is held between the centers, that is why that is called cylindrical grinding. When the workpiece is not between centers, that is why this is called centerless grinding. What is that center? This is one. These are called centers. Now the work is held between center. What is the center? This is called live center. This is called dead center in case of lathe. So the work is held between live center, and that is why this is called the work is held between centers. So this is the work is between centers, and there the work is not between centers. That is why centerless. That's all. So here the workpiece is held between the centers and it is fed horizontally. That means it is moving horizontally. So the surface grinding you see here, this is the grinding wheel, and we have the workpiece here. The workpiece is fed against the grinding wheel. So the operation that is happening is on the surface. So you so the surface grinding you have seen where the work is reciprocating under the wheel. So that is feed motion is given to the table. That means feed motion is given to the work, whereas the tool is rotating. So when I say form grinding, here you can see here the grinding wheels. What are they doing? So here the grinding wheel is in the shape of a particular shape of this gear to finish the gear, to make the finishing operation on the gear. So here you see this is the gear tooth to machine means to finish the gear. This is actually is produced by milling machine. Suppose the gear wheel. After the gear wheel is produced machined by milling machine, then we to have the finer finishing touch and having finer dimensions for the gears. Then we use this grinding operation, which is called form grinding, where the wheel itself is in the form of the tooth which you want. So here you see centralized grinding means now there are two wheels. One is regulating wheel and the other one is grinding wheel. So if you see the workpiece is now just freely suspended between those wheels. Let us see. So now the workpiece is coming from that side back. Of course, there is a small support here just not to fall the workpiece. So the work is coming forward because on its own by friction because of the supporting wheel inclination. So hope you understand what is the difference between this thing and let me see, is there any doubts between is there any doubts? Any doubts? So is it clear what is the grinding and all? So if you have no doubts, let's check. So if you have any doubts on grinding, let us post. If not, I think now we come to an end of our Mantech course, Manufacturing Technology 1 course. So this is the final topic which we wanted to complete, grinding. So if you don't have questions, we will stop and then we will discuss remaining agenda for today. Yeah. So if you don't have any questions, let me see what is the next thing which we want to do. We want to have some discussion on final exam, that is in extended assignment. Before going to that, I ask you to answer SSRT, first do it. And then there is one more survey which I need to guide you. I will guide you in 1 or 2 minutes, then you can do at yours. So before just going to final exam discussion, let us have our SSRT first. Hello, please answer the questions because there are only 60 people. No new fill-ups today. Instead of my announcing here 2-3 times, but no new fillings, huh? So okay, you try to finish it as early as possible. Okay, let us come to our class. So as we were discussing, there is one more survey which you need to answer. Of course, there is some time for it, but still, I would like to mention it now itself. So there is one survey that is called Course Outcome Survey, which means that what are the COs of this course, that is manufacturing technology. Let me tell you. Based on this, you answer your survey now or at your leisure time, but this also to be answered. So what is it? Your manufacturing technology CLO is apply the knowledge of solving complex engineering problems in the area of engineering, metrology, casting, machining, joining, and vacuum casting 3D printing. So this is one objective. And next objective is apply ethical principles and commit professional ethics in manufacturing process activities and responsible norms of engineering practice. Number 3 is able to function effectively as an individual and as a or a leader in diverse teams. That means this is all group activity. That means this subject has 3 COs. One CO is regarding metrology, casting, joining, and printing, 3D printing. So I think that we learn very good. The next one is CEO2. That is ethical principle commitment, means your lab and how you work with groups, and that is that one. General one. That is regarding the lab, how you work in teams. Number 3 is how you, as a diverse team, how you are um, working. So these two, CO2 and CO3, are of regarding the project and lab. Unfortunately, we don't have lab face to face, but anyway, virtual labs you have attended. So based on that, you can answer this survey about CO2 and CO3. CO1 is straightforward knowledge of solving engineering problems in the area of metrology, casting, and machining, joining. So all that we learned. So this survey also you have to answer. I think you already received some reminders from ACS to answer this survey. So try to answer this survey at your convenient time, or if now also only 3 COs you have to answer, because in the survey there are 10 COs, 9 COs. Don't worry about it. There is no that many COs for any course. Only 3 COs for any course. So first 3 only you answer, remaining you just leave it or not applicable. Not applicable or leave it. That's all. But the first CO1, CO2, CO3 you have to answer. Anyway, I will upload this CO1, CO2, CO3 also in ULearn so that you can answer while answering. You want to see what is CO1, you can check here. What is CO2, you can check here. So I will upload as a separate file this one, COs. You can answer there. So that is regarding CO. And so thank you. Now let us, if you, as I said, we want to discuss something about final exam. So any doubts so far? If you have any doubts, just let me know, and otherwise we'll continue. So for the final exam, as I said, you will have 2 questions. The 2 questions spanning to every topic, because you have 24 hours and it is a open-ended question, just like what we have in our exam 2. So in exam 2, we have some question like some component is given and you have to ask, you are asked to write about the manufacturing method or something like that. For example, in your examination, we ask this question. I think, are you able to see the screen, the component? Are you able to see the component? Are you able to see now? So this one, suppose if some of you have answered what is the operations that are performed, means you have to refer to this object and then you have to give the answer. Like for example, in this component, threading is there, step turning is there, and then you have holes, means drilling is there. So these operations, when you illustrate, you have to illustrate with the component in mind. Some of you have answered like just in the textbook knowledge. For example, this component also same operation. This component also same operations with knurling, taper turning, knurling, and grooving. So this, if whatever component you got, you have to refer to the component and then explain the operations. Everybody knows those 3 operations: turning, taper turning, threading, and those things. But you have to give with reference to this figure. So then only you can get full marks. Similarly, as I said already, I am marking the exam 2. So some of you have done good. So those who have done correctly, that means fully, they are okay. Those who are not, they will get less marks. Okay. So in the case of final exam, there will be two questions. Both questions you have to answer. And again, that is an open-ended question, which means not only for this subject, all subjects you get open-ended because you have 24 hours. So in the final exam, you need to what you call refer to all manufacturing. Like we started with your metrology, joining, casting, and machining. Not one chapter. All chapters are required because you need not read or by heart. You refer that section and you refer what is your suggestion or what is your method that is required. So whole manufacturing technology topics which are discussed in this course are required. There is no single chapter like in exam 2 only learn cutting tool materials, only learn casting, not like that. It is not quiz exam, it is a final exam, which means you need to have the knowledge of all the course, all the topics you learned so far from week 1 to week 12. And while answering the questions, remember I already gave you a sample of what will be there in a final exam, exam 2, a component, something like that. You have to, there is no copying. Some of you are just copying from others. That will not help in this case because everyone is have to think separately and then give your own idea. Suppose you want to use you can use CNC, no problem. What I said is, suppose in the case of the objects which I have shown, that can be done by lathe or as well as CNC lathe. Doesn't matter. What is your solution? That is the problem. That is the idea. So you can give any solution, whether it is CNC machine or a normal lathe machine. That doesn't matter. Only thing is you have to give solution how to do it and what to do it, because ultimately you are not using the machine. You are only giving the description. So that is how we do second final exam, extended assignment. So be ready with that, and you try to give your own solution. Maybe it should be very elaborate, not like exam just giving you maybe while correcting your exam 2 scripts. I found some of you say turning operation, just heading and then one textbook sketch. That will not help. That will give you only 2 marks, 3 marks, not full marks. If you want full marks, you have to give description how this object is machined, like turning operation means with reference to that particular object. So for example, casting, we never tested you. Let me give you a casting example, because you know what type of objects with the machining, because exam 2 you have some training, but casting we never tried. Suppose I gave you some dumbbell, your component is dumbbell. Suppose your question, I give you the dumbbell, then you have to propose what type of casting that dumbbell can be produced. You know, while discussing our chapter, we can use it shell molding, or we can use sand casting, we can use shell mold casting, we can use other castings like die casting or something like that. So what casting is proposed by you? Suppose I gave you how to manufacture dumbbell, something like that, and then figure is given to you. Then you have to give the proper. Don't worry about the solution. There is no unique solution. As I said, dumbbell can be produced by shell molding. Somebody on phone, some of your friends say, shell molding is correct, and somebody says, no, sand molding is correct. Both are correct. You go according to your wish, according to your study or understanding. So whatever you understand, this method is useful, or this can be used. Yes, you can. And then just not name. Say for example, for dumbbell, you give name and then answer finish. No, you don't get 50 marks. 50 marks for dumbbell manufacture. The dumbbell can be prepared by sand casting, one line, and then submit. No, you don't get, you get only 5 marks or 2 marks, not 50 marks. If you want 50 marks, you must give what kind of a stand casting, what is the procedure in stand casting, what is the pattern type, what pattern you use, what are the pattern shape, and then what is the riser design, riser, how the riser is placed, where the riser is placed, what is the material you use. Suppose dumbbell can be manufactured by steel or by cast iron or by aluminum or what, or rubber. I don't know. You select. Okay. So accordingly, you have to give the method. Suppose your dumbbell is rubber, you can give something else. Your dumbbell is steel, you can give something else. Your dumbbell is aluminum, you can give something else. The procedure changes according to your material that is selected by you. So that is how you have to answer. So it is like a report. You assume you are a manufacturing engineer, you are producing a product, and then start from scratch. How do you prepare a report? You prepare the report. That's all. Got my point? So any doubts you can ask now. So I already uploaded your exam 1 marks. Already your lab marks are ready. Exam 2 marks also I will upload in maybe 2-3 days, maybe 2 days. Already almost correction is almost done. So exam 2 scores you can visit your exam scores in uLearn maybe in 2 days. I will send email, of course. Then you have anything you can verify. If you want to verify your exam 2 script, I will upload in the cloud. We download your script, marker script. Huh? So that is regarding exam 2. Exam 1 marks you know, lab marks you will know soon. Quiz marks already you know as and when you answer. There is any pending thing I will do. Those who are absent for any exam or any quiz, just let me know within this week. Next week I don't entertain any what you call any missing exam. You somebody missed some exam 1, somebody was mailing me exam 1, he don't have any score. If that kind of a thing is there, you have to resolve within this week. Next week, no re-quizzes, no re-exams, nothing. Anything we have to close before Friday. So anything else? If you want to ask anything, you can ask in the mic or in the chat. Oh, okay. So if nothing, we will take a leave and okay, see you in next semester in some course or final. I mean, hopefully face to face next time. Yes, very good question, Tash. Thank you for raising this. It should be handwritten only. All answers should be handwritten only. Some of you are cutting and pasting from textbook. I will give 0 marks if cut and paste. You have to write with your own hand. And another announcement I forgot is you have to write your student ID on the every paper, on every what you call paper. Page, every page, yeah, every page. Page 1, page 2. If you use 10 pages, all 10 pages should contain your student ID, not first page. One problem which I have faced in your exam 2 is many of you have not noted down your student ID, you just uploaded. But while downloading, I am not sure whether you copied or somebody else's paper you uploaded. So that's why you must put your student ID with your own handwriting on each page of your answer. At least first page definitely, last page definitely. If not all pages. If you forgot one page, okay. If you forgot everywhere, I will suspect that shift and I have to scrutinize whether it is written by you or just downloaded from your friend. So inform all others who are not here also. They have to write their student ID as well as handwritten only, no typing. Okay. All sketches also handwritten only. Sketch also handwritten. Because obviously we used to have sketch. For example, casting, as I said, some shell casting. You have to do your own sketch by handwriting, not cut and paste from textbook. You can refer to any material in the web internet, textbook, anybody, because you have 24 hours. You can browse anything, contact anybody, refer any book, no problem. But it should be your own handwriting. Mr. Harpreet, today's quiz, because as I said, those who are in the class at 5 p.m. only can answer quiz, because only when there is quiz, so many logins. If there is no quiz, no login after the quiz. So anyway, if you miss the quiz, if you miss many quiz, then I will consider it. If you miss this only quiz, no problem. You won't get much effect. But if you quiz, if you miss many quizzes, you'd write to me. Okay, thank you. If no questions, we will see you next semester in some course. Okay. Okay. You please answer SSRT and COS whenever you have time. SSRT within this week. Please answer those surveys, because if you don't answer again, I have to send reminders. So I don't want to send reminders on that. Okay. Thank you.